So in this video, we're going to be talking about direct variation. It starts with the problem, if a car travels at a constant speed of 25 miles per hour, complete the table and graph below. All right, so if a car drives for 1 hour at 25 miles per hour, then at the end of an hour, the car's driven 25 miles. After 2 hours, the car would have gone 25 times 2, which would be 50. In 3 hours, that would be 75 miles. And in 4 hours, 4 times 25 would be 100. I go ahead and put that on the graph. And I will let my x values be time. So 1, 2, 3, 4 hours. My y values be the distance. So I'll just go up by 25. And then I will plot my points. So in 1 hour, they've gone 25 miles, 2 hours, 50, 3 hours, 75 miles, and 4 hours, 100 miles. All right. So is this relationship linear? All right, so if we connect the points, we can see that these are definitely making a line. We can also check the rate of change here. And we can see that, yes, this is going up by 1, this is going up by 25. So there's a constant rate of change. So yes, it's linear. We can see that from the graph. We know the constant rate of change is y over x, the change in y over the change in x. So that would be 25 over 1, which is just 25. Is it proportional? So it does make a straight line and it does go through the origin. So then yes, this would be proportional. And then what equation could be used to express this relationship? All right, so we know that in order to get 25, we had to multiply 1 times 25. In order to get 50, we had to multiply 2 times 50. So we were doing, in order to get this value here, we did 1 times 25, 2 times 25, 3 times 25, 4 times 25. So we could write the equation that says that this is x and this is y, then my y values are equal to 25 times my x values, times my x. Or if we use these other variables, the distance, the y, is equal to 25 times the time, times t, okay? And if we take out 25, we know that 25 was the speed, right? That's really the rate that they were traveling. And what we have is what is called the distance formula. Distance is equal to rate times time, and you'll see that even on the star chart. Okay, and you may use it slightly different in science. Okay, distance divided by time equals rate, or I can't remember, y'all. Or, I don't know. Y'all use something different, I think, in science, but it's all from the same formula. It's just been rearranged. So this distance formula is an example of what we're going to be talking about in this stop. And anytime you have this relationship, this proportional relationship, you should already have that written down, but this proportional relationship is also called a direct variation. All right, so for some reason we have lots of names for the same thing. So a proportional relationship can also be called a direct variation. And anytime you have an equation in the form of distance equals rate times time, that's always a direct variation. This is an example of a direct variation equation where you have 2 variables and you have this rate of change in front of the x. The constant rate of change can be called the constant of proportionality. We've seen that before. Okay, it can also be called the constant of variation. Okay, because again, proportionality and direct variation are are just different ways to describe the same thing. And we're going to see later that this is also called the slope. So in the next chapter, we're going to talk more about slope, but they all really are describing the same thing. The equation for a direct variation is y equals kx, or k is equal to y over x. And this is when k is the constant of proportionality, or the constant of variation, or the slope, or the constant rate of change. It's all using just different wording for the same relationship, okay? So we're going to use this equation and this just this verbiage in order to describe different relationships we see in tables and graphs. Okay, so in the next example, it says determine whether the relationship is a direct variation, which really they're just asking you if it's proportional. If it is, it says state the constant of proportionality. So basically that's the constant rate of change. And then express the relationship as an equation. So you're using this right here as the equation where K is the constant, or K is the rate of change. Okay? All right, so if we take a look at this first one, if I'm looking for a rate of change, a constant rate of change, then I need to compare the change in X, which is 1, to the change in Y. This is 12, this is 12, and this is 12. Okay, so there is definitely a constant rate of change. If it's a direct variation, then it also needs to be proportional. Okay, so I can see if there's a constant rate of change that's definitely linear, so it's got that part of the proportion. Would this also go through the origin? So I want to know is if the time is 0, then what is the amount of his wages? Well, 0, right? If he's going to work 0 hours, he's going to get $0, and we can see that this change in the rate is still the same. Okay. All right, so I would say yes, this is direct variation. The constant of proportionality, they want you to use the word K, or the letter K. We're going to see when we call it slope that they change the letter to M, but again, it's really all the same thing. So because we're using direct variation, we're going to leave it as a K. It's the change in Y, so the Y change was 12 over the change in X, which is 1, and that just simplifies to 12. Okay, so the constant of proportionality, it is a direct variation. The constant is 12. And the last thing they want is the relationship as an equation. So if I just use this part right here to write the equation, then I'm going to say Y equals, and I'm going to replace K with the constant X, 12X. Okay, yes, constant is 12, equation is Y equals 12X. All right, look at number 2. Those pizzas cost $8 each plus a $3 delivery charge. Show the cost of 1, 2, 3, and 4 pizzas. All right, so when I buy a pizza, it's going to cost me $8 plus the delivery, so that would be $11. 2 pizzas would be $16 plus the delivery, which would be $19. 3 pizzas would be 3 times 8, which is $24, plus the delivery charge, which is $27. 4 pizzas would be 4 times 8, plus the delivery charge, which is $35. All right, so again, if I go ahead and put these on my graph, I'm gonna let my X values be the number of pizzas. This would be 1, 2, 3, 4. And then I'm gonna let my Y values be the cost. And this would be, let's see, how about 5, 10, 15, 20, 25, 30, 35, 40. Okay, so 1 and 11. So 1 and 11 would be a little more than 10. 2 and 19. 3 and 27. That's about right there. And then 4 and 35. Looks like right there. All right, so if I draw the line that connects these, it definitely makes a line. Okay, but in order to be a direct variation, okay, it also has to be proportional. Or just a different way to say the same thing. So is this line going to be proportional? Well, it's linear, but does it go through the origin? No, because of the delivery charge, even if we go down to 0, right, there's still, it's going to be off, all right, because of the delivery charge. So this is not going to go through the origin. So this is not a direct variation, which means you can't use this equation here in order to solve it. Now, there is an equation that describes this line. We're going to learn more about that in the next chapter. There's still a constant, but it's not the constant of proportionality because this is not a proportional relationship, nor is it a direct variation. Okay, so not direct variation. All right, determine whether the relationship is a direct variation. If so, identify the constant of proportionality and explain what it represents in this situation. All right, so we're starting with the equation y equals 10x. That represents the amount of money Y Julio earns for X hours of work. So all I have to go on is this right here, which matches the direct variation equation, y equals kx. So in this form, this is a direct variation. It's pretty much the same thing, right? So I would say, yes, it's direct variation. The constant, k, would have to be the number 10. Okay, and then I'm asked to explain what that constant represents in this situation. So Y is the amount of money he earns. X is how long he works. So 10 is his rate, right? So 10 is the rate, per hour. Okay, $10 is the rate per hour. See, that's what he's earning per hour. All right, look at number 4. The equation y equals 25x plus 10 represents the amount of money y that is charged for buying X number of shirts online plus a $10 shipping charge. Okay, so again, before I can decide if it's a direct variation, based on an equation, right, I'm looking here, is this in the same form as y equals kx? Well, if it didn't have the plus 10, then I would say yes. But because of the plus 10, it's not a direct variation. Okay, so there still may be a constant rate of change, but that only tells me it's linear. Okay, in order to be proportional, it has to go through the origin. This line is not going to go through the origin. All right, it's starting, if x is 0, it's still gonna, you're still going to have to add 10 to that. So it's not going to go through the origin. All right, and therefore it's not proportional. If it's not proportional, it's not a direct variation. If y varies directly with x, write an equation for the, let's see, let's go ahead, sorry, not a direct variation. Let's go ahead and say y, not proportional. Doesn't go through the origin. Okay. All right, if y equals 14 and x equals 8, determine the value of y when x equals 12. All right, so it's already told me that y varies directly with x, which tells me I can use k is equal to y over x. So if I'm looking for the constant, I can do k is equal to 14 over 8, and I can simplify that by 2. That becomes 7 over 4. Okay, so when I write the equation for this, it would be y equals kx. So now I know k is 7 over 4 x. So I can use this equation now to determine the value of y when x equals 12. So now if I replace x with 12, y equals 7/4 times 12. Make that 12 over 1 so that I can multiply. And then if you cross simplify, right? Okay, I can't simplify this way, but 4 and 12 are both divisible by 4. So that gives me 1 here and 3 here. 7 times 3 is 21. 1 times 1 is 1, which simplifies to 21. Okay, so y is equal to 21 when x is 12. Okay, or because I know that when I have a direct variation, that's another way to say proportional, then I know I could also set up a proportion, okay, where I'm comparing y to x. So remember proportions? You can use your boxes when y is 14 and x is 8. What's the value of y when x is 12? Okay, so I'm solving for y. And then how do I do that? I cross multiply 14 times 12. It would be 28. Start with a 0. That's 168. Then I divide by the 8. So if I divide 8 into 168, it'll go twice and then once. Okay, so y is equal to 21. So again, I'm going to get the same answer either way I do it, but you have some options here. Okay, on number 6, it says determine the value of x when y is 14, y is 7, when x is 8. All right, so if they tell you, and they have, that y varies directly, then you know you can use y over x for k. Okay, that's a y. All right, so then y is 7 when x is 8. So the constant is 7/8, which means I can plug it into this equation, y equals kx. So y equals 7/8 x. All right, so now if I look for, I'm looking for x when y is 14. So if y is 14, I'm solving for x, right? So if I cut this in half, I need to solve for x. So I'm going to be dividing by 7/8, dividing by 7/8. Okay, so what is that? That's really 14 over 1 divided by 7/8. So when I divide fractions, I keep the 14 over 1, change to multiply, and flip to the reciprocal. And if I cross simplify, 7 and 14 are both divisible by 7, right? And if I multiply, 2 times 8 is 16 over 1, which is just 16. Okay, so this is x equal to 16. All right, so that's one way to solve it. That's using the direct variation equation. Or if you remember that direct variation is just another way to describe a proportional relationship, then you can use a proportion. right? Y over x, so 7 over 8. Y is 14. X is what I'm looking for. If I use the proportion, then I would multiply 14 times 8, which would give me 112. Divide by 7. Be 1. 7 I'm going to 42 6 times. Okay, so x equals 16. Okay, so again, both ways are going to give me the same answer, and that again, you just have different ways of doing it. Okay, math is cool that way. There's often several ways to solve one problem. Okay, so just kind of to sum it up, don't forget that really we're using a lot of terminology to describe the same relationship. Direct variation is just really a proportional relationship. Okay, the constant that you're finding in a proportional or a linear relationship, it's to be proportional, it has to be linear, and it has to go through the origin. Okay, if it's linear, it has a constant rate of change. All right, that rate of change, constant rate of change in a proportional or direct variation relationship can also be called the constant of proportionality. It can be called the constant of variation. We will see that also is called the slope. Okay, this is the type of equation that you're going to see. Any proportional relationship or direct variation relationship will be written in this kind of format, this equation. Constant can be found by dividing y over x. K is just the letter they use to represent that constant. Okay, all right, see you soon.